Good afternoon. My name is Colin Mazzola. I'm with a company called Wellington Management, and I'm here today to talk to you about our journey going all in on AWS. But before I get to that, I just have to say I flew all the way out from Boston hoping for some great weather in Vegas, and it rains, which is just unbelievable. It rains like 4 times a year in Vegas. So a little bit about what I'm going to talk about today. First, I'll give you a brief overview on who Wellington is and what it is we do. I'll talk about our migration and how we've gone about it, including the timeline. And then I'll focus mostly on lessons learned that we've come across over our many years doing this migration. And I will leave time at the end for Q&A for people who have questions. My compliance team made me put up a disclaimer that I am not an investor, so my views are solely my own and have nothing to do with any investment advice, so please don't take any of this and go trade in the market. So a little bit about Wellington. We are an asset management firm. We're an independent business, a partnership. We manage about $1.1 trillion on behalf of our clients. And to give you an idea of scale, there's just under, give or take, 1,400 total resources in IT. That's a mix of employees and consultants. And my particular role at Wellington is I have a dual role. I'm responsible for 5 lines of business IT teams, sales and marketing, the fund group, product management, a couple others, and then as well as the IT infrastructure, so the core data center servers, network, security, and storage as well. Now, one thing that you may be asking is, how is Wellington unique or different? And you're going to be talking about this migration, Colin, and are those going to apply to us? We're a bigger firm, or we have different requirements. We do have some unique applications that are quite interesting. One in particular is we do a lot of analytics. And as an example, we calculate all of the pay downs on all the mortgages held in the United States, basically on a monthly basis. And that's called prepayment risk. And so although we are a smaller firm with not that large of an IT shop compared to some, we do some relatively large analytics workloads that are fairly unique. So a little bit about our business application tech stack. Our front end is a mix of different technologies, mostly HTML, JavaScript, but we certainly have our fair share of now what are legacy technologies with Java Swing, Java FX, .NET. Our middle tier, for the most part, is Linux of some flavor. We've had just about every flavor of Unix over the years that you can possibly imagine. We do have quite a bit of Windows as well. I'd say it's maybe 15%. And we give our developers lots of freedom. They can choose more or less any language. So if you can name it, we've probably got it somewhere in the environment. A couple of my team members are here, and they can attest to that. And our data is mostly stored on a large relational back end. We do have a growing presence of other technologies. We use most of the AWS services, be it the various flavors of RDS or S3 as well. We're starting to experiment with things and do some things with things like Aurora. So we have a fairly varied technology stack. One thing that may be a little bit unique is most of our applications are custom built. So roughly 75% of all the applications that we run out of the 800 are built in-house. And we do that because we believe that if it affects the investment process, that it can give us a competitive environment. One of the most important things, though, is how we get to and why we started this migration in the first place. And so when we first started back in 2009, we wanted to experiment. This was very early days. AWS was more or less EC2 and S3. There weren't a lot of other services. And so we started to build a handful of internal IT applications just to see what the service was all about. The VPC concept didn't even exist. And the very first thing that we built was an internal IT application to automate our architecture review checklist. It allowed people to fill in what particular pieces of technology they were using, and then for the architecture team to say, OK, yep, those make sense. So that was the very early days. Where we started to get serious was in 2012. And the gap between those years was really because many of the core services that now you take for granted didn't exist in 2009 to 2012. So the very first thing we put in production was that mortgage paydown calculator that I talked about earlier. It was very compute intensive. We were doing it internally by attempting to CPU scavenge off of a number of different idle servers, especially in the non-production environment. And we found that if we migrated it to Amazon, it was much less expensive to run. We didn't have to scale up our farm internally just to run this once a month. One of the key things in 2012 was our head architect was really thinking a lot about, okay, how can we use cloud services more? And he went to the reInvent conference in 2013, and he came back, and we sat down and had a conversation. He goes, it's just so amazing. They're doing so many amazing things. I wish we could do that. And I said, well, why can't we? What's holding us back? And he paused and he said, well, I think there's a couple of things. One, we need to be able to encrypt all of our data with a key that we would control. Okay, so we wrote that down. And he had a couple other key things, but that was really the first and foremost. Well, lo and behold, they announced KMS. So, or actually it was Cloud HSM at that time. So lo and behold, the key things that we thought we needed in our environment to be able to go more to a cloud environment started to materialize. So between 2013 and 2014, 2014 is when we made that all-in decision. It basically happened right after the reInvent conference with all of these things getting announced. We really started that point thinking about all of those capabilities that we would need. And then, hold on a second, I gotta scroll my notes. And we started to migrate simple things, non-production systems, systems that didn't have a lot of highly proprietary data, to gain some experience. And as we did that, we became more and more comfortable in the environment. We started to realize that we needed some tooling in order to make this what we would consider easy to operate and production scale. And that took some time, and I'll talk more about that in a little bit. The next step that we did is we're starting to migrate applications. We've made this decision to go all in. And I often get asked the question, how easy was that? Being a private partnership, having a lot of autonomy within the firm, there's a lot of trust, mutual trust. And so it was a difficult decision, but it was one that we were ultimately able to make. The key next step was in 2015, as we're starting to migrate these applications, getting to a DevOps model. And this was, I would say, the moment when things really started to take off and started to change for us. Up until this point, we operated what I would call a fairly traditional IT shop. We had infrastructure teams separate from applications or lines of business teams, separate storage team, server team, security team, all of those types of things. And in 2015, we said, if we're going to embrace this and use all of these great tools, we're going to need to change the way we operate. And so we did what I refer to as the fantasy draft. We literally had each one of the line of business teams in a room and said, we're going to do things differently. We're going to go to a DevOps model. I want each of you to go and think about if you had to do your own patching, if you had to allocate your own storage, if you had to handle all of your own deployments, how many people would you need? And here's the pool of people that exist within the infrastructure team today. And who would you like on your team? So everybody left, they thought about it for a couple of weeks, we came back, we had a second meeting, and everyone came back and said, all right, here's what we need, here's how many people we would like on our teams. And what we realized is that each team actually needed a fraction of the total capacity that we had in the core centralized teams. So at the end of this, we had lots of undrafted players. We still do maintain to this day small, what I would call core service teams. So we have a team that just maintains the scripts and the kind of core tooling around our AWS environment. That team is a total of 5 people, I think, in total. Is that right, Brian? 5? 3. I was adding 2. Is that a request for 2 resources? Okay. So it's a very small team. We have another team, though, that handles all of the kind of core security infrastructure. That's a handful of people. But all of the other DBAs, sysadmins, former storage admins, et cetera, are all now out in the teams. And so they're not in a centralized organization anywhere. In 2017, so just this past year, we migrated our very first, what we would call tier 1 system, mission critical, can't go down, can't have a blip, no how, no way system. And that was our portfolio accounting system. And this is actually a vendor application, so we had the uniqueness of it being our first tier 1 system, but also the complexity of the fact that it is also a vendor application, which, based on my earlier comments, is not our strong suit. We are much more comfortable with our own code that we can debug ourselves than we are with somebody else's code. But we migrated that, and that's gone really well. I don't think that's had any major issues. The owner of that application is sitting right here in the second row. And so that's gone really well. And that was a big milestone because that was the first time that we had said, OK, we now understand how this is going to actually operate on something that is truly mission critical. And then our goal is still the same as it's been for all the years since 2014. We're going to shut down our data centers at the end of next year. By the way, don't tell the team. We've all told them it's June, but we can actually go to December. So the goal is to be at the end. And why did we pick that date? Because our lease is up. So simple reason, the data center lease is up. We coincided with that. And so we're going to move out at that point in time. A little bit about the size of our environment. These are a couple months old at this point, but we've got what I would consider a fairly sizable environment, and especially when you consider that we have 3 people on the central team that maintains a lot of these stacks, for example. So 10,000 stacks. We have, I won't go into this in too much detail in the subsequent slides, but we have a lot of workspaces. We're also in process of migrating our entire company over to workspaces as well. And there's many, many, many more. I just couldn't fit them all on one slide. If there's a service that Amazon offers and it's not in the IoT or video space, we probably use it in some way, shape, or form. So how do we manage 10,000 stacks? So first of all, I guess what I would have to say is on the prior slide, you may have noticed we have a lot of VPCs, so 362 VPCs. And why do we have so many VPCs? Simple reason is we like to isolate different workloads from one another. And so we have each account, or each area, functional area, has a separate dev, test, stage, and prod. And then some areas, so we'll have fixed income, dev, test, stage, and prod. There may be a second one because the fixed income business is so large, so we'll have fixed income 2, dev, test, stage, and prod, and so on and so forth. So if you take the 362 and you do the division, there's really only, I'll call them 50 to 60 logical segments within our environment. And we've done that largely because, as I'm sure many of you have, we tried to do the network segmentation project for 10 years. And we could just never get our arms around re-IPing our entire network. It was just too complex. But moving into the Amazon environment gave us the opportunity, we're going to have to do it anyway, to redo that. So we have really segmented at a very small level. And I'll show a slide later on some of the results of that. We have built, though, lots and lots of tooling around allowing us to manage this many stacks with such a small number of people. So there are lots of templates. We use CloudFormation as our main tool, and we've built a lot of custom deployment tools around, and you can see kind of the logo slide on your right, a bunch of different tools. We've integrated those into our kind of core ITIL ticketing tool, and what that allows us to do is a lot of the developers aren't even aware of what's happening behind the scenes. They know, they go in and they fill out a change ticket. They fill out these couple of forms on, okay, what VPC is this thing going in? What's the name of your stack? And where's the deployment archive? They click, submit, and it magically happens. And they don't actually even understand how it's occurring on the back end. So even though we have many, many, many stacks, because of the automation, the environment feels smaller than it really is. So So I thought I'd talk a little bit about how we got to this point, specifically on the telecom and colocation side. So when we first started out, from 2009 all the way to 2014, we didn't have any colos, we had no dedicated lines, we were literally riding an internet pipe to the AWS services. We had a handful of VPCs, and that was about it. And that worked really, really well for a long time. Until we made that all-in decision, we experimented and actually rolled out, as you saw, real production systems. However, when we started to think about if we're going to go all in, we're going to need a more resilient environment with multiple paths that we feel confident can't fail. That's when we started to up our game and think about how we are going to actually make that happen. So all the way through the early years, just an internet line. The first thing we did when we made the all-in decision is say, you know what, we should have a colo facility. Because if you're actually going to shut down your data center, there's going to be a whole bunch of stuff that you're probably still going to need that may not yet run in AWS. I'll talk more about those in a little bit. So we built out one colo facility, a couple of firewalls, direct connect lines, dual lines for redundancy. Pretty simple. That worked well for us for a while. And as we started to think more and more about, OK, if we're truly going all in, how are we going to deal with resiliency and redundancy? What happens in a disaster recovery scenario? How is that all going to work? We said, if that one colo fails, we're going to need another colo. It should be far enough apart that we feel confident that they're not going to be taken out by the same event. The network team actually rented a van, drove down to the two colo facilities while they were stalling at the equipment. They dubbed, this is a true story, they dubbed the van the loser cruiser. Drove down there, installed all the equipment, and had a great time, saw that they were far enough apart, and felt good about it. One thing you'll notice is we went from dual lines, we now have a tertiary line as well. And we did that because there was a specific event where Colo A was active, Colo B was active, Colo A had a maintenance event, so that had to go down, and Colo B, one of the network providers, decided that they needed to have maintenance on the same weekend. So we had one colo with one line active for that period of time, and our business is such that we can't be down ever. And if we are, we're out of the market, and if we're out of the market, we're doing a huge disservice to our clients. So we basically just have an internet backup line to each colo. Again, it's the lifeboat style. We hope we never have to use it, but we did that one particular weekend. So as we're starting to think about tier 1 applications and how we're going to run our most mission-critical workloads inside of AWS, that is when we started to go multi-region. And by the way, again, when we first were doing this in 2014, 15, US East 2 didn't even exist. It hadn't been announced. We kept asking our sales team, hey, when are you going to have this second region? Don't worry, it's coming. And eventually it did. And so then we built out another colo facility, again, to give us direct connect access into US East 2, aka Ohio. And we have redundant lines, again, between those as well as directly to us. So last but not least, I guess I should talk about, we're now building out for our workspaces environments small, more or less cross-connect points such that our workspaces traffic doesn't have to route, say, from Singapore all the way back to the US to get to a workspace inside of Singapore. So we're building out facilities, just very simple. It's typically, we rent to have a rack at most inside of a colo facility, and we're going to have a couple of those in Europe and a couple of those in Asia. But I think what you can see is that this was very incremental. We didn't just one day wake up and say, we need a whole bunch of colo facilities, we need a bunch of gear inside of those facilities. We were able to do it very incrementally without a lot of initial investment. It allowed us to dip our toe in and make sure that we were still confident that our strategy would work. So what actually stays in the colo facility if you're going truly all in? Not a lot. We have maybe, I think we're up to 2 racks plus a large monolithic centralized database server. But those racks hold the firewalls. Occasionally, we have a vendor that delivers a specific VM that has to run on a specific type of virtualization software as an appliance, and so we run those in there as well. We do still run our own voice and video infrastructure. Market data, so most of the market data vendors still today will provide you an actual router that you need to put in your facility. You got to cable it in, so we do that. We do have some NAS shares in the Colo, and again, we did look at using AWS services, but because we use some legacy protocols, it was easier to migrate some of those NAS shares. And last but not least, our big centralized databases. Most of our data is in fundamentally 3 big relational databases. And we looked at migrating those into Amazon. In fact, we tried. We spun up a whole series of, we did it ourselves. It was too big to fit into a single RDS instance, and we didn't have the time or the fortitude to attempt to break it up just because there's millions and millions of lines of legacy proprietary SQL code inside of these things. So we tried to spin it up in EC2, our own templates, and what we found is that it was still really complicated. And so we decided to lease a series of these appliances that this vendor provides, basically to buy us a bridge. And we're going to keep an eye on how do the AWS services evolve, and do we have to do that next time. And again, one of the things I guess that we've really learned as we've done this is, if you're going to go all in, there are going to be a lot of obstacles in your way, and at some point you may have to back off of perfection and say, you know what, we're going to let this one thing live in the Colo facility. So we're still getting rid of the data center. You could argue that a Colo is a data center, but at least it's not at the same scale, right? It's a very small number of things, a handful of racks like I talked about. Okay, lessons learned. The number one thing that we found out very early on is you have to really think about your fault domains. So we did a lot with VPCs. We had lots of different VPCs, and that worked really, really well. If anything, we probably swung the pendulum too far and had too many VPCs. And we're slowly but surely starting to say, you know what, having fault domains is really good, but maybe we don't need quite so many. So 362, maybe we can get to 250, give or take. But that is an important feature that we have found, is having things in different, truly segmented parts of your network makes a big difference in terms of resiliency. If you're anything like us, we would have, I don't know, I'd say at least 3 or 4 times a year the incident where a person would say, I thought I was in stage and I was actually in the prod environment when I ran that script. We've seen that more or less go to 0. We don't have those issues anymore because of all of the isolation between the environments. Almost every application that migrates, we really encourage, this is kind of one of the core principles, for them to run multiple servers, multiple EC2 instances, rather than just one. And if possible, make that auto-scaling. It's not always possible, but for the most part, we try to do that. Multiple AZs. We used multiple AZs to get kind of that cross data center resiliency. That has worked really well, and I'll talk a little bit more about how we enforce that as well. But one important thing is we don't do cross-region for everything. We do cross-AZ for everything. We enforce that for every single application, regardless of how simplistic it is, but we do not enforce cross-region. Cross-region is not easy. It is harder. It is more complex. It is more costly. And so we don't enforce cross-region. We only do it for the core critical tier 1 applications. We try to monitor all of this, because if you tell a team, hey, don't do this, you can be sure that over time somebody will forget and that message will get lost. So you need some way to monitor that. And I'll talk about how we use Netflix's Simian Army pattern as a way to do that. And I already talked about the separation between the environments. So one other thing we did when we went to Amazon is we said, this is an opportunity for us to fundamentally change our security model. We can make things much more resilient and much more secure than they've ever been, because we have the opportunity to do it all new. And so we built out a Bastion model. So every single server that a person's going to attempt to get to has to actually go through a Bastion host. And there's no other way to get there. And that is enforced via, you'll see on kind of the middle, it says monkey ensures this rule is not overridden. We have a process to make sure that that SSH path is never overridden. And actually, the guy who writes that is sitting there in the second row. And that enforces that you have confidence that no one can get to that server without having gone through, again, our integrated ticketing system. So if you're a developer and you're DevOps and you need to patch a server for whatever reason or deploy a piece of software, whatever the activity you need to do is, you're going to go through the ticketing system, you're going to be prompted for your credentials, you're going to put in two-factor. We enforce two-factor for all of this as well. And then you're going to get in. And you're going to get a restricted shell that only shows you the list of servers that you're allowed to see. So it really narrowed down what people could do and dramatically changed our security of our environment. It's also made things like the SOC 1 a lot easier because we can just push the report and say, here's how it works. And once the auditor becomes comfortable that the model is secure, you just give them a list of here's all the accesses that have happened. So I talked about this briefly, but I'll go into more detail. One of the most important things we learned is it's great to have good resiliency patterns, but if you can't actually enforce that the teams are using them and enforce them automatically, it will drift over time. And so the first thing that we did was use this simian army pattern that Netflix has come up with. We used to talk about the chaos monkey at the leadership team. Do people know about the chaos monkey? A few? Okay. So the chaos monkey in Netflix is effectively a process that runs inside their environment and randomly kills things. And the theory behind it is if you randomly kill things in their production environment, you will have to recover gracefully, otherwise you won't be able to, you'll have incidents constantly. So we use that pattern. We don't actually kill things randomly in production, but we use this concept of having a monkey that's automatically doing things and enforcing the pattern automatically. And I'll show you a little bit more about that in a minute. But we found that really important because then you don't have drift in your environment. If you have an idea, a good architecture pattern, you don't get drift from what that pattern says you want to do. So even though we are a financial services company that deals in billion-dollar trades on a daily basis, we felt we could still learn from somebody like Netflix. And I guess I would say that to me was another key thing that we've kind of explored over the years is regardless of what industry, there are so many industries using the AWS services that you can learn from other industries that may have different problems, but problems that you can learn from in ways that you can exploit those learnings as well. One other example that I'll go through on how we've automated something is over time, all these applications are starting to use different AWS services. Even some of our critical tier 1 applications are starting to use things like S3 or SQS. And what we found is over time, you may have built a dependency that the team didn't fully understand. So we wanted to make sure that teams completely understood that. So we've built in tooling that tests and enforces testing on which services the team is using and can they gracefully recover if one of those services fails. So for example, there was an outage a couple of years ago, I guess it was last spring, spring of 17, where the S3 service was unavailable and then degraded for 4 or 5 hours. It made the news, it was a big deal, and we had some applications that were impacted. So we built some tooling to say, okay, in the future, if you have a service, we're going to figure out how to make S3 appear inaccessible such that if that happens again, the application knows how to react. And in that case, that particular application that was impacted, they were just using it. It was a tier 1 critical application. They were literally just using it to cache some data. And we said, well, to read some data on startup. But rather than cache it, they were reading it every single time. So we said, well, why don't you just cache that data? And if you cache it, then you don't have that dependency. You still have it at startup, but you don't have it at runtime constantly. So here's a list of our actual monkeys. This is straight out of our wiki page. I can't tell you when the IP restriction monkey and the IAM monkey actually runs or what it does because the CISO won't let me, which is funny since he works for me, but he still tells me what to do. So we have a whole series of ones. So tagging, we really enforce tagging. That's absolutely critical. We shut down non-production instances automatically if they're unused, so that way they're not taking up cost. We enforce that IP restriction, which is the Bastion host thing. We make sure that certain rules, certain IAM rules aren't violated, so you don't put in the kind of any rule that anything can get to anything. We are looking at all of those types of things, and there's many more beyond this, but this is where we have spent a lot of time and a lot of effort, and it makes a big difference in keeping our environment pristine. We found that it doesn't drift as much over time as it had in our legacy environment. Here we go. So I talked about this briefly before, but I'll go into a little bit more detail on how we actually enforce that automated BCP so that we can be sure that if somebody builds an application, that it in fact can fail over with minimal or no human intervention ideally. So these are screenshots straight out of our ticketing tool where we have integrated into our AWS environment. And basically what happens is we now test, rather than kind of twice a year BCP style tests, we do it every quarter. And you have that quarter to conduct a test manually, if you would like, or on the last day of the quarter, if you've done nothing, your application will be automatically killed in a specific AZ, and we'll see if it recovers in the other application, or in the other AZ. And if it does, great. If it doesn't, all right, now you got some work to do. Our theory is that, in general, developers don't like to do the same thing over and over again, right? I think that's a general truism. If you make it so that it's the easiest thing is what you want the teams to do, we want you to automatically recover, we want you to make it simple for you, they will do it. And so we found that most teams now are automating their recovery to make it simple. But this process enforces it so that we know at the end of every quarter we get a report, here's everything that hasn't been tested, here's everything that failed on the last day, here's all the problems that happened. Okay. The number one question I get when I talk to folks is, what happens if AWS goes down? By far the number one thing. And attempting to say, well, AWS isn't one thing, and it's a lot of different things, typically is somewhat of a fruitless exercise. So you have to be prepared for that question if you are going to go all in. And there's going to be a lot of FUD, right? There's going to be a lot of questions that may not make sense on their surface. So you need to create your story and keep it simple. So what we do is talk about, all right, and we make analogies to our current situation, right? We've got one data center here, we've got a backup data center there. In AWS, instead of one data center and a backup data center, we have 5. And if all 5 of those were to fail, we have a whole nother series of data centers, US East 2, aka Ohio, that has a whole nother series of data centers. Using analogies has worked really well for people to understand, hey, we're going from 2 to many more than 2 with many more network lines. It makes people much more comfortable. That graph is our incident trend from, I think it's 2010, basically the end of 2010 through October. And what you will notice is, I think that this shows that our environment actually got a lot more stable, more or less, a year into us doing a lot of migrations. Now, I can't say that's completely causal. Some of it is because it's amazing how resilient and stable technology is if you don't touch it. If you just stop touching stuff, it's amazing how it just works really well. So that was one thing. But what we found is, as we've migrated into AWS, we've almost made a step function in the resiliency of our applications, and I think the data kind of bears that out. Now, it's still going up, and we would expect that too. Some of those are lessons learned, things that have failed, things that we didn't expect to work exactly the way, or fail in exactly the way, and we've learned those over time. So I talked about tagging. These are the tags that we enforce in all of our stacks. I guess what I would say is that number one thing you need to know is, if you're going to control cost inside of AWS, you have to know who owns something. If you don't know who to go talk to and say, hey, why did you spin up 10 X1 servers last night? You have no way of being able to control it, unless you're just going to shut things down and cross your fingers that it doesn't have an impact. So the number one thing we wanted to enforce was so that we knew who to go talk to. Who could we go question about, why is this particular thing costing so much? That's fundamentally the app ID. That maps back to our CMDB so that you can find all the detail in there. The other thing that we did is we used tags as a way to let those monkeys that I talked about earlier do automation. So for example, the uptime tag allows us to say, hey, I expect this particular stack to be up from point A to point B, and if it's not supposed to run on Saturdays and Sundays, the monkey knows it's safe to automatically kill. If you put in 7x24, the monkey will say, okay, fair enough, I won't shut that down. Most of the other tags in here are just to make it easier if you're in the AWS environment, that you don't have to take some key from the CMDB and go look it up in the CMDB. So it makes it a little simpler and faster to go back and forth. So another thing on cost is you really do have to think about, and we've evolved ours over time, a cost containment approach. Reporting is really critical. So this is a screenshot out of a tool that we've built inside of Tableau that takes all the AWS data and maps it using those tags to dashboards that the management can use. So this is one particular line of business, our corporate team. It shows it in this particular case by environment, prod, stage, and test, and you can see the costs. And it gives that manager some indication of, okay, does this make sense? Is this environment cost what I would think it would? And more importantly, if you look all the way on the right, do my test environments cost less than my prod environment because I'm actually shutting them down? What we found initially was everybody kept everything up all the time. Even though we had the monkey to shut down things in non-prod, everybody was putting in 7x24 in that tag and leaving it up all the time. So having a report that shows that makes the manager much more, they understand more about what their costs are. Another key thing is that we have isolated the big costly mistakes to that team of 3. So for example, we only allow that team of 3 to buy reserved instances. That's not a free-for-all that everybody in the entire department can do. And that means that, yes, there will still be waste in the environment. It's in any IT environment, you will have waste. But that the waste is at a smaller dollar increment than it is in our existing environment. When we first decided to shut down our data centers, we sent a team down to do some clean out of one of our primary data center, and we found servers that were in some back room that had literally never been unboxed. That's just wasteful. So you will still have that in this environment, but it will be at a smaller dollar increment if you can manage it well. Last but not least, one of the things we have done is historically all of the costs were always centralized. They were in my budget. So I paid for all the servers and storage, and when we first went to Amazon, or in the first couple of years, actually all the way through this year, all of the AWS costs are still in my cost center. Next year is the first year we're going to take that and break it out, and each line of business IT team will have their own budget. And that was done intentionally. The reason is we didn't want to create a reverse incentive mechanism where going to the internal data center was cheaper than going to AWS because they didn't have to come out of their budget. So we wanted to wait until we were almost all the way there before we split up the budget and gave it to the individual application teams. But now that we're 90-something%, the last few applications are not meaningful in terms of their cost, we'll be able to push that out. And now each line of business manager will have their own budget and they'll be responsible. So they can make a choice. Do they want to spend it on hiring more developers to tune the code, or do they want to buy more hardware? So another cost trending report we've put together in addition to kind of the by environment view, this is also out of Tableau, is by application. And so the bubble chart on your left just shows you how much does that application cost. This is one of my teams, and I use this as, do I think that application, the OneView Data Mart, should that be the most expensive application? Does that make sense? In this particular case, it does. It's a core data mart. It's used by, being used by almost every single application in this area, so it makes sense. But that only gives you part of the picture. The other key thing is you have to be able to trend this over time so that you can see, are the costs going up, going down, or staying the same? So you see the green line at the top. That's a particular application. That's another data mart. That's the legacy one that we're trying to decommission. And actually, sorry, the green line is the new one. The yellow line right below it is the legacy one. And you see it had a massive spike. So when that happened, I called up the team and said, hey, what's going on? Why is there such a big spike in this application? Why is it going up so much? And the answer was, oh, we're backloading all of the historical data. We need this period of time to backload all the historical data. It will start to go down. And if you notice, it's gone down and actually started to flatten out. So the key here is it becomes every person's job. Every manager in IT has to understand the cost. You have to own it. It no longer becomes somebody else's problem, which at least in our environment, it was always someone else's problem. Unfortunately, the someone else was me. Okay, last on costs. You should really be prepared if you are going to go all in, and we chose to go all in on a single vendor, AWS, for the lock-in question. And this is the second most common question in addition to the what if Amazon goes down. The theory is, in my view, there is always lock-in. No matter what you choose, you are locked into something. So if you're choosing a multi-cloud provider, instead of being locked into AWS, you're locked into the multi-cloud provider. And a lot of those vendors seem to have ties into some of those legacy software vendors who I know how they act. So we made a conscious choice to say, if we're going to be locked in, we would like to make a conscious choice on who we are locked in with. And the interactions that we've had with AWS give us confidence that we're locked in with the right partner. And I'll give two examples. The first is we do a quarterly review with our account team. And the first thing, and her name is Stacy. Stacy comes in with the team, and the first thing they do is say, here are the ways we think you could save money. You're running too big of an instance here. These 3 instances are underutilized. Maybe you can consolidate them. Not, hey, we're having a big sale. I need to make the end of the quarter number. We need you to buy something. That's always been my experience with other vendors. So AWS comes in, and the first thing they're doing is they're telling me, here's how I think you can save money. So that gave me, and I think the rest of the management team, a lot of confidence. And one other thing was actually preparing for this session, another little anecdote. The team that was prepping me said, you know, you've talked a lot about the good things. You should talk about some of the challenges that you've had. So again, that was another reinforcing kind of moment for me to say, we're choosing the right partner. They're not just looking for the rosy side. They actually want this to be real and in it for the long time. So the thing that you hear over and over again about being customer obsessed from AWS, at least in our experience, has been very true. Let's see, what else? Another thing, at least one person's viewpoint, and I think the team's viewpoint, if you start to go to multi-cloud or multiple providers, you end up having to solve the same problems in multiple different ways because each solution is slightly different. So you're going to end up having to figure out how do you do your network, how do you do your security, how do you do all this tooling. We thought it was a lot simpler and cheaper just to go with one solution rather than do multiple. And at the end of the day, there is some optionality, right? The AMI that EC2s ultimately use as their runtime is effectively a de facto standard at this point. You can pull AMIs out and put them into other services. We don't view that as something that would be simple or easy. We know we would lose all of the tooling that we've built on top of CloudFormation and all the other AWS services would be lost. But it is if we had to, we could do it. And last but not least, before I open it up for questions on the management, the hardest part for me personally was learning the lingo. This is an alphabet soup of different terminology. You got to know your EC2, your SQS, your S3, your Lambdas, your X1s, your T2 micros. You need to know all of that stuff. And it gets a little daunting initially. Just spend some time, go to the website, learn some of the documentation, have somebody on your team walk you through it. I do think it is important. And part of the reason it's important is a lot of the tools are fundamentally different. The notion of an availability zone and a region and an AZ1, availability zone 1, in one VPC is not the same physical data center as availability zone 1 in a different VPC, right? It's a logical construct. So you have to start to learn those types of things. And so I would highly encourage everyone, spend some time on that. Another key thing is, I talked about this already, migrating to DevOps really was the moment when this all started to go a lot faster. Up until that point in time, we had a small number of people, I would say it was on the order of 10 or 12, who were highly skilled in AWS. Now our entire department is skilled. Everybody is skilled because they got some skilled resources off of this centralized team. And last but not least, This journey is more difficult for less technical resources. I talked about the fantasy draft and the undrafted players. At the end of the day, the people who struggled the most, and a lot of them left, were people who didn't have that core technical skill. And I guess I would say it's the difference between, you might have a person who is a sysadmin who knows how to administer versus a sysadmin who's really a developer, right? They can absolutely write the best script you've ever seen, and they're always trying to figure out how to automate stuff away. Those people are incredibly valuable in this environment. But it was a really difficult time because we had some people who couldn't make the transition. And with that, I will open it up to questions. There are 2 microphones here on the left and right, so if you have a question, if you can come down to the front. And if you don't have any questions, ooh, quiet group.
Just a question about your services and how you said you're using pretty much all the services. How do you guys get those services approved? Because I know for us, there's a ton of services, and we struggle with being able to approve them with legal and compliance and so forth. How have you guys handled that?
Yeah, so one of the people who does that is sitting here, and he was nodding his head because in general, the development teams, Andy Jassy or Werner Vogels announces something at 8:03, they want to use it at 8:04. In fact, they want it even sooner than that most of the time, even though it's not announced. So what we do is that is owned by that small central team. They're the ones who open up which services are allowed. We have some set rules. So for example, one of the rules is if it stores data and it's not KMS enabled, we don't open it up, right? Until it supports KMS, we don't open it up. So that's we have a set of guidelines that say if it meets these, we don't have to have a long talk with legal. Because we've set out we will only open things that meet the following criteria. There are some cases where another example of that would be we don't use any of the workmail, workdocs style services because in our industry, as I think everybody here knows, you have to store all communication between your clients. And so we don't open those up as well. So we have a set of guidelines or a set of rules, and as long as the service adheres to those rules, we open it up. If it doesn't, we don't, unless a team really puts together a good case. And then we'll go through the long drawn-out process of working with the legal and compliance team.
You mentioned that AWS team encouraged you to share some problems. What are some problems?
I would say the problem, I kind of alluded to it, is we tried to migrate our big legacy centralized database, and it didn't work. And I shouldn't say it didn't work. We had basically built a very complicated architecture that was costly to run. And what we were attempting to do is we were attempting to replicate a feature in this particular product that allows automatic failover of the JDBC driver, right? It automatically fails over within like a second, and we were trying to replicate that same level of resiliency inside of AWS, and we just found that it was quite complicated. So although we're still optimistic that over time that will improve, we didn't feel that worked for our particular application yet.
You had mentioned that your central database was too large to migrate out to AWS. So I was just curious if you implemented replication and change data capture to move some of the data out to AWS.
Yeah, so we do use a replication tool, and we in fact take many copies of that data and put it into different read replicas all over the place. But the way that database is constructed, there are many schemas that are cross-linked with database links and stored procedures that would make it difficult to actually segment it out into truly isolated applications. So it does not need to more or less stay together, but we at least have been able to take some of the read workloads and put those into different places.
Do you perform any writes to AWS, or do all of the writes come back to your Colo?
All of the writes happen within that centralized database appliance for those databases, but we have many, many other data, Redshift, Aurora, Postgres, all the various flavors of RDS that are in fact write for those specific applications. But those 3 centralized databases are only writable within that appliance, which lives in the Colo.
Okay, just one last question. I was just curious, you had an automated BCP plan. which was very interesting. I was wondering if that was kind of based on using that simian army under the covers in that automation.
I don't believe it is. It's just a series of ServiceNow forms that in turn kicks off custom scripts that we've written, mostly Perl.
Okay.
Mostly Perl, right, Brian? Yeah.
Thank you.
Oh, just the shell script.
You talked about DevOps as being this key inflection point, but mostly you described it from the point of the organizational design change, the decentralization of these previous infrastructure resources. One question I had for you is, did you automate the majority of that CI/CD, sort of platform that you showed as a visual prior to decentralizing, or after you changed and distributed those roles throughout the organization? And
I guess the way I would say, we had attempted to build that prior to decentralizing, but we never had a lot of uptake. And when we started to migrate into the Amazon environment, by having a fully built environment for deployment, teams were much more likely to adopt. In the legacy environment, teams had their own ways of doing things that they have developed over many, many years, and they fundamentally didn't want to change because they knew how to work it. They had people, it was easy for them. But moving to Amazon, every team has more or less adopted that tooling now because it was simpler for them. They didn't have to reinvent the wheel because it was provided to them.
that's the carrot side of that equation. Was there also
Was there
a
a
policy-based, sort of stick to keep them from diverging in how they automated? And
Yeah, we try to use the carrot as long as possible, and then we beat them with the carrot. So I would say in general, we try not to do too much stick if we don't have to. And I would say this is actually something we learned when we went out and visited with the AWS. We did the executive briefing, and we met a guy, Lou Mason, who runs the AWS core website. And we asked him kind of a similar question, how do you incent people? And he said, hey, we try to incent them by making it easier to use our service rather than go off and build your own. So we've more or less adopted that to say, you can use whatever technology you want. If you don't want to use our deployment pipeline, you knock yourself out, you could build your own. But why do it if it's simpler to use the one that's already pre-built for you?
My question was somewhat similar. So you have a centralized CI/CD process that all developers use?
Yeah.
Okay. So we have over 15,000 developers. We're the roadblock in a sense for everyone else.
Yep.
So we moved to more of a bring your own pipeline with API governance. So the other question I had was around IAM and roles. What we found was people try things in the sandbox, then they try it in dev. Doesn't work because we use least privileged. Oh, can
Yep.
you do this? Open up this. We do that. And then can you open up this? So we end up in this big back and forth. Try to automate that, but new things are coming out all the time. So how do you set like these guardrails where you give them enough privileges, but you don't necessarily slow them down?
Yeah, so I guess we've done that fundamentally, if I'm answering your question correctly, in the VPC construct. Inside of a single VPC, and really the 3 or 4, dev, test, stage, and prod, inside of those 4, that application team has more or less all access. They can do whatever they want inside of that. But in order to cross VPCs, that's where they have to start getting into putting in rules. So I didn't talk about this, but all of our traffic, we started out, if you wanted one VPC not in those 4, if you wanted 2 functional areas to talk to one another, they would actually go through a centralized VPC we call Infra 1. So you would have to talk to the Infra 1, and in order to get that rule put in, you'd have to come and put in a change control ticket to say, I want this particular service to talk to that service so that I can get my communication back and forth. The number one thing we found on deployment nights was that teams had messed that up. So they would go to deploy, they would find out they'd missed one thing, they'd missed one particular rule, one particular server in the cluster, whatever it was, and then it wouldn't work exactly. We've gotten better at that over time, partially, and maybe this is a little bit of the stick part, is you don't want that to be too easy for teams to forget that they forgot to put in an IAM rule. So we started deferring some changes when teams messed it up. And nobody wants to defer their change. And so that was one way that it worked. We don't do it all the time. I'm not claiming we do it. But if you do it a couple of times, the message gets out and people don't want to do it anymore.
Okay, thank you.
Hey, so in the beginning you mentioned you had one systems engineering team and a bunch of developers, and then you merged them together. You know, each software team probably said, okay, I need 2 systems engineers in my team. And so, yeah, and then later you mentioned how now everybody is DevOps and everybody has like this systems engineering knowledge. And I wonder if there's any insight, like what was the motivation for the developers to say, okay, we have a systems engineer in our team, that's all we need, that's great, he does the info stuff. I don't see the motivation for the developers in that situation to take on any of the infrastructure tasks.
Yeah.
Do you have anything to share about that?
Yeah. So this is one person's view, but I guess I would say is what we noticed is if there is a faceless, nameless team that services your requests, you're much more willing to just put in whatever ticket you want. If that person, if that sysadmin sits with your team, you know them, and you know that that's the only person, over time what happens is people want to be cross-trained. Like they don't want to have to go to ask somebody else to do something for them. They're like, oh, I don't want to bother Steve. Let me ask him, can you teach me how to do this? So over time, people got better. And you know, some of the things that I would consider relatively basic, we had over the many years lost the ability to do. Kind of you know, Linux has tons and tons of performance tools built in, and people just had lost either the desire or the knowledge to actually be able to run something like IOstat on their application and figure out what it's doing. What we found is now, I would say the developers are kind of increasing their skill in some of those core things because so much of the rest of the infrastructure is automated away. Now, Brian, who takes a lot of these phone calls when it's really thorny, will tell you it's not nearly where it needs to be. We still need more skill, as I'm sure many of you feel the same way, but it's getting better. And I feel like it's getting better because teams know how to do those basic things. So that to me is the difference is if the person's sitting in your pod with you, you're much more likely to say, hey, can you teach me how to do this? And that person's more willing to share.
Right, awesome, thanks.
You didn't mention the mainframe. Do you have a mainframe?
We don't have a mainframe.
Good.
We had, we used to have a HP 3000, which ran a bunch of Pascal code, but we luckily decommissioned that about 5 years ago.
Yeah. My second question is around CI/CD pipelines. Have you automated the integration testing, performance testing, security inspection?
Some teams have, some teams have not. So that would be a team-dependent answer. There's no centralized way that we enforce that, though. We do use a lot of, kind of testing tools, but teams are free to choose their own. A lot of them use things like Selenium, but there's not one and only one standard.
Perfect. Thank you.
First of all, thank you for sharing your story. The question that I have, you partially answered with the VPC peering, but in terms of, given that you have so many VPCs and decentralized model, from a data governance standpoint, do you see a lot more, data getting fragmented, multiple copies? Because you won't find it in the cost models because you're coming from such a high bar or high cost. You won't see that in AWS, like from a data governance and other areas.
Yeah, it is, I guess I would say it is, we do have lots of copies of data. We try to keep track of them. That is a difficult problem. I can't claim that we have completely solved that. There's no doubt that we replicate data way more than we should between environments and different functional areas as well. But it is, I'd love to say that we've completely solved that, but I don't think we have. We have tried to put rules around. So for example, I didn't talk about this, but you can't make your VPC internet accessible without somebody knowing about it. And in fact, if it becomes internet accessible, it's automatically made inaccessible immediately right after, and then an alert sent to the security team. So we have some of the data governance to prevent true data leakage or confidentiality problems. And there are certain areas where we use additional security measures with things that require like personal PII, that type of thing. But for the most part, I wouldn't say that we've completely solved the data governance problem.
Okay. But cross VPC, you just allow traditional traffic. Like I can query RDS.
You
on
do, but again, you have to
go
open
through
up you have to open up a rule to even let those two VPCs talk in the first place.
Okay.
So I think we're out of time. I will still be here. I'll be out in the hall if you have any further questions. Feel free to contact with me, and don't forget to fill out your evaluation on your app. Thank you very much.